Welcome to you all participants for the fifth presentation of the Sustainability Engineering series. Today's topic presentation will be made by Dr. Ajit Sadnis. I request Secretary of the Bangalore Center Association of Consulting Engineers, Mr. Shrikant, to kindly welcome the participants. Mr. Shrikant.
Thank you, sir. Good evening to one and all. Dr. Ajit sir, good evening. Dr.
Good evening,
Manmohan
sir. Good evening.
sir, good evening. Dr. R. Jagdish sir, and good evening. I welcome all the participants to this series evening lecture, the fifth one. Earlier we had, in the last session, we had lecture from Mr. Kalbavi, which was again an eye-opening lecture for us. Very fantastic lecture by him, and we had lot of inputs. And today we are going to have another lecture from Dr. Ajit Sabnis on computation in buildings using real-time data reconstruction phase. I welcome one and all, and without taking much time, I hand over back to you, sir. Dr. D. Rangnath, sir.
Thank you, Mr. Shrikant Sanal. Friends, I welcome all of you for the fifth presentation on the Sustainable Engineering series, organized by the Association of Consulting Civil Engineers India, Bengaluru Center. Just to recap salient features of the earlier presentations, I'll just take a few minutes for this. Presentation 1 on why sustainability is the need of the hour, basic terminologies and definitions, was presented by Dr. Ajit Sabnis. This presentation laid the foundation for the entire series. We discussed on the impact of built environment on the nature, understood several terminologies related to sustainability, sustainability goals that we engineers are directly connected with, the planetary boundaries we are crossing, the biodiversity loss, etc. Next, the presentation 2 was on elements of inclusive green construction and design parameters. In this, we learned various aspects of embodied energy, embodied carbon, LCA methods, benchmarking, and parameters of sustainable design. Next, the presentation 3 was on embedded energies, geo-specific sustainability development indices, and their role in sustainability quantification. In this, we learned about computation of embedded energies of materials and systems with some practical examples. We also got enriched with the knowledge of how to approach sustainability with whole building approach using SDI. All these three presentations were made by Dr. Ajit Sabnis. Presentation number 4 was on optimizing and saving water in achieving green construction. This was presented by engineer Rajendra Kalbavi. He briefed us on the importance and necessity for using the three components of water, light, and air in a balanced manner for a sustainable life. Explaining the dark truth of scarcity of water that the world is driving itself towards, he touched upon the efforts we need to put for the sustainable construction using green building technologies. He impressed upon all of us that by default, it is the responsibility of each and every technocrat to work in the field of economic water usage in construction. Engineer Rajendra Kalbavi shared with us his knowledge and experience on optimization of water usage in construction. Friends, Today's presentation, talk number 5, will be on sustainability computation in buildings using real-time data pre-construction phase. The presentation will be made by Dr. Ajit Sadnis. Through today's talk, we will be looking at establishing benchmark values, computation of sustainability for individual and building clusters. This assessment is of primary importance during the construction. And here is Dr. Ajit Sadnis making his 4th presentation, and this is the 5th of the series. Dr. Ajit Sadnis.
Yeah, thank you very much. Here to allow me to share the screen, Ranganath.
Yeah. Oh, you had gone out, right? Where are you? Can I talk again? I don't see you here. Ajit Sadnis, okay.
Yeah.
Okay, 1 minute. Okay, you got it?
Yeah,
Okay.
I think again it has gone.
Oh. 1 minute.
No, my presentation has gone.
Ah,
So,
but are you still the presenter? You have that?
yeah, I have it. Yeah, are you able to see the presentation now?
Yeah, it's coming on. Yes.
Right?
Yeah. Please go ahead.
Yeah, good evening, participants, and welcome to you for the talk number 5 of the series. It has been a wonderful response from the students community, and also we are getting quite a good positive information, and then positive, quite a good encouragement from all the institutes, especially from the colleges, that this has been quite useful. So that is a good motivation for ACC to take forward, and a good step by ACC Institute. So till now, as Ranganath has explained, we have talked about, in the last, I would like to just recall what we discussed in the last talk. And we talked about the finding material suitability using the figure of merit. And this figure of merit was derived as a mathematical expression comprising of all the 2 important properties of the material, and then cost stimulants of the materials. And then this is what we saw. We also saw the equations, and we also saw with an example and case studies as to how this figure of merit can be used in addition to embodied energy and then embodied carbon, can be used to select the material and taking into consideration several other parameters. And we also saw how this particular figure of merit and embodied energy, embodied carbon together, integrated together, how we can actually put them in the ranges, how we can classify and how we can actually do it for the a system of a formwork, etc. And then you remember we also discussed about these charts, how the entire material classification can be done once we have the embodied energy and then embodied carbon and the figure of merit all put together, how the whole building can be and the materials can be assessed. So we took few materials from the material chart under metal category and then under ceramic category. And then this is what you're seeing now. And this is all these things which we actually saw. And we also discussed what exactly is Sustainability Development Index, comprising of so many things, and then how it can be developed and then evolved for a particular, with reference to climatic conditions, climatic regions, and maybe including, it's possible also to include some of the seismic zones, etc., but it has not been included here. But we can develop sustainability development indices through all those things. And then we also talked about the sustainability development indices. There are several sustainability development indices developed with respect to specific regions across the world. And this particular thing, what we are discussing, comprises of about independent and dependent 28 ecological and then engineering parameters. So this is what we discussed in the last slide. Then when we come to the next slide, we will start from the today's this thing. And built environment primarily interacts with the three critical elements of our biosphere simultaneously. And these three important material, one is the construction materials, what we have. And then the second one is the embodied energy aspect of it. And between the two, there is an interaction that happens. And third one is the greenhouse gases, which are already locked in. And the interaction between the three items are actually can be represented, and what we actually have, the synergic effect. This actually is the symbolic representation of all the interactions, and by each element by itself is dynamic, and then actually we calculate, quantify these interactions, which eventually help us in evolving mitigation strategies for achieving sustainable development. And this essentially now we will go in for. We also discussed in the last slide few equations, how mathematical equations interactions can be evolved using these several parameters. We discussed about interaction 1, interaction 2, interaction 3, and then how we can evaluate the total I, which actually is the we have taken here as the sum of the three interactions together. Now, we have talked about how to evaluate embodied energy, embodied carbon, I mean, taking the entire life cycle of a building into consideration, and then computing or analyzing a building using Sustainability Development Index. We also saw that in the last session, higher the SDI percentage in case of an individual parameter represents higher interaction value and hence lower sustainability. So SDI methodology provides us clarity on performance of individual subsystems, overall impact of the whole building system during pre-construction phase, information in respect of selection of suitable alternative materials from recyclability, embodied energy, embodied carbon perspective, selection of materials using the concept of figure of merit, ranking the building in terms of sustainability assessment beyond criteria-based evaluation. So these are the primary advantages of using a geospecific or climatic specific sustainability development indices. Now the question comes, in this particular class, we will see how do we go about it and what exactly are the various steps, how do we evaluate these things using the Sustainability Development Index. Now, the first step and the foremost step is actually establishing the baselines or the benchmarking values. Now, benchmarking of a building how does it help? It actually helps us to provide a set of measurable baseline values that can be compared with the real-time performance values of a building to be assessed for sustainability. Now, second important benefit is this comparison facilitates optimizing the overall performance of the building which is under assessment. Third thing is the real-time performance values as compared to baseline values provide us an indication of sustainability level of a building in relative terms and expresses in terms of percentage. What I mean real-time performance values is actually based on these values. These are the bill of quantity values. That means the drawings are frozen bill of quantity is frozen. All the quantities which are supposed to get into the building or form a part, constitute the entire building, are actually available to us. And then it is this data which actually gets into the construction of the building. And then that is approximately equated to the real-time data. And once we have this as a step number one, we identify this particular building, and then how does the benchmarking process goes. Now, while for doing the benchmark process, we need to actually establish what exactly is the goal for the benchmark. Are we doing the benchmarking? Are we establishing the benchmark for embodied? Are we establishing it for embodied carbon, or are we establishing it with respect to perspective of sustainability development, or an integrated approach? The goal for establishing the benchmark should be absolutely clear. And then the second point should be, we should be absolutely clear in terms of the input and output matrix that actually as parameters which come into the picture. This particular slide aspect of it we will see in the next slide. And we also need to collect sufficient data for the benchmark project. In the sense, the benchmark project, what we take for reference should be actually should be eligible to become a benchmark project. We cannot just ad hocly take some project as a benchmark project and then compare it with us. No, that doesn't happen. So we need to collect a lot of information that is required for the benchmark that makes that project eligible as benchmark project. And there are several methods to doing it. Then the formulation and then the tabulation in the way what we require. Then comes the analysis and interpret sustainability ranges and assess sustainability level. Actually, this is a procedure which we adopt, which we use for assessing the benchmark project. Essentially, the same benchmark will happen with the process will happen on the main building or the other analysis also. Now, while doing this, buildings for benchmarking purpose, I may take one building for benchmarking today, but it is not necessary that that particular building will ever remain as a benchmark building, because there are a lot of methodologies, there may be efficiency, there might have been much more optimization, better generation, new generation materials might come in. So this benchmarking project, what we undertake, has to be evaluated from very frequently, from time to time, establish, validate it, and then only can be considered. Second important aspect is benchmark building selected for comparison should be validated or compared data and research. So this is an important point. Benchmark building and the building to be assessed for sustainability should belong to the same typology. This is another important parameter that is to be considered. That means I can't compare benchmark project which is taken for the, let us say, a commercial building. I can't use that parameters, that as a benchmark project for assessing a residential building or some institutional building. So this is what it means. Benchmark building and the building to be assessed for sustainability should belong to the same typology of the building. These important factors are to be kept in mind for the benchmarking process. Now, we talked about the input and output matrix, which is to be used. And then as per ISO 21931, baseline values have to be used while assessing sustainability levels in buildings. Now, what are the inputs? That should be clarity. Here in this particular case study, what we are taking up, embodied energy becomes an important input matrix. Similarly, embodied carbon, density of material, modulus of elasticity, cost of material, cost of construction, transport energy, design life, and the global warming period, potential period. Here, the global warming potential period is considered as 100 years, and the design life is also considered as about 50 years. Now, what exactly is the output? What are we trying to measure? We are trying to measure the overall energy per square meter, overall emission of greenhouse gases, and then what exactly is the figure of merit, emerging out of it, so that suitability of materials can be considered, and what is exactly are the various interaction values which will help us to classify the building into the 4 categories which we are going to discuss in future, and the sustainability index which will express the percentage of the building or the impact of the building at the conceptual stage itself. So this is the, once we have the clarity on this and actually clarity on the benchmark data, we actually have all the parameters to go forward. Now let us take it by a case study. How do I have, for example, I have taken this building, particular building, as a case study building, as a benchmark building. This is one of the important, one of the landmarks as a sustainable building. I would not like to name it because of certain privacy matters. So benchmark building, embodied energy, and then computation. Last time we have very clearly discussed that let us go ahead systematically. How do we calculate embodied energy for this benchmark building, embodied carbon for the benchmark building, and then from with the sustainability development index perspective, how do we establish the baselines? And that is what we are now trying to do. Now, you kindly focus on my cursor. So this is the various, the entire data collected for the benchmark project has been taken and then has been essentially categorized into these 10 primary parameters or subsystems, whatever you may call. So all concrete works are put together, steel works are put together, including the reinforcement and the structural steel, block masonry, etc. Otherwise, it becomes too complicated and then too elaborate. So once we calculate, like what we have explained, we have seen how do we calculate embodied energy for a particular material and also for a system, for a composite. So based on that, once we calculate the embodied energy of this particular benchmark building is coming to 3,522.62 megajoules per square meter. When we express this in and represent this in a pie chart, we have these same percentages. These can be percentages. You can actually see from the embodied perspective, concrete, which actually contributes to about 49% of the total impact, has the maximum megajoules embodied energy per square meter. So similarly, steel work also, which actually plays an important role. It has got about one of the important things, as we discussed it last time, from embodied energy perspective, formwork also plays actually an important role, and the brick masonry also plays an important role. So now this will actually help us to understand which are those systems or subsystems in a particular thing, in a particular building, which actually contribute to higher impact. For example, waterproofing or painting. So we may talk about painting. There is not much we can save on painting. We may use low VOC paints, etc. Only painting has to be taken not from sustainability point of view, but majority times it is taken from the health point of view and indoor quality, air quality point of view. So now this is from embodied energy perspective, this is the scenario of the benchmark building. Now let us go to the calculation or benchmark building of the carbon computation. On similar lines, what we discussed, all the 10 parameters or 10 subsystems of a benchmark building have shown here, and we have actually arrived at 316 kg CO2 per square meter as the value for the benchmark project. Now, please don't get confused by this table. I know this is a very complicated table, but now, as we have discussed it last time, and we have also seen last time, to calculate the sustainability development index and while calculating the three interaction values, we need to, the categorization of the subsystem will remain same, but we need to identify which are the higher and lower ranges of the total interaction value, and then we arrive at the total I value of the building, and then SDI percentage can be calculated, and then mean SDI percentage can be tabulated. What actually is important for us is this total, the pink column where my cursor is moving, this is the total interaction value. So the lower range is 9,705.9 and the higher range is 17,122. The mean of that can be taken as whatever it comes to 17 plus 10, about 13,004 and odd, comes as 13,414 is the mean value of the total interaction. And then the last column gives you the mean percentage wise. So if this, we actually consider this and then put it back in the same abstract format, we have from sustainability or from the interaction point of view, for the benchmark building, the distribution, symbolic distribution of the things can, subsystem can work here, and you can also see. As I said, the mean value, mean interaction value becomes 13,414 from the tabulation what we saw. Now, friends, there is an interesting observation to be made here. See, from sustainability point of view, concrete actually plays a very, not as a big role it played in terms of impact, sustainability impact from embodied energy and embodied carbon perspective. When you start looking at it holistically and then at a much larger picture, taking several eco parameters into consideration, concrete, the steel has got the maximum impact and the concrete has got comparatively a less impact, which actually, this is why, this is mainly because we are now looking at it at a multi-storied buildings, the frame structures where RCC is predominantly used. And then when you look at it only from the embodied energy and then embodied carbon point of view, yes, carbon has got, concrete has got maximum impact for the simple reason that cement is involved in it as a part of it. Now, but when you actually distribute it over the entire design life of the concrete structure, when you look at it from the maintenance point of view and from the from several reasons, from the durability point of view, all these things, when we take it from the integral perspective, from the, that is what the sustainability development index gives us more realistic picture than comparing it only with one of the or few of the embedded energies. So this is what an interesting factor, and this actually is a good news for all the cement industries. And this is what the analysis is for the sustainable development. Now, thus, we have now established, these are the, for the baseline values which are actually established for the benchmark project. We have a benchmark value of embodied energy, 3.52 gigajoules per square meter or 3,522 megajoules. Embodied carbon is 316. Then mean interaction value is 13,414 and SDI percentage is 100%. Because when we take this as a benchmark project, and this for us is taken as 100% sustainable, it cannot, see, it cannot be zero embodied energy or it cannot be a zero embodied carbon. There is no building which can go carbon negative. It's impossible. So there has, because there are a lot of materials involved in it. So embodied, there is certain amount of embodied energy has to come in, embodied carbon has to come in. So the least one, which we have taken it as a benchmark project, we have taken it as SDI percentage is 100%, which indicates that for the comparison purpose, this acts as a benchmark or the. Now, how do we know that this, what the benchmark project, what we have taken is exactly the benchmark? As I said, it has to be validated. How do you validate it? There are 3-4 important things to validate it. One is there are a lot of researches which are happening and then tables which are being published. So that is one way of looking at it, looking at those tables and then identifying the typologies of buildings and arriving at. Otherwise, now we can also compare it with the criteria-based green rating systems which are available for this particular purpose. Now, let us say if this building goes for LEED rating certification. Now, when it goes for LEED certification, the criteria has been developed by one of the associated professionals of the LEED certification. And now look, this particular building gets about 101 points out of total 110 points, which comes to that if this building would have gone for LEED certification, it would have got platinum certification, and then we are almost extremely close to meeting the criteria, which is 101 out of 110. Now, similarly, if you go to the other aspect of it, now if you compare it with the IGBC certification, if benchmark building would have been given to IGBC, IGBC would have given us total out of 75 marks, it would have given us 71, which again comes into the platinum range. So this benchmark building and 316 embodied carbon and 3.5 gigajoules per square meter is one of the lowest embodied energy and then embodied carbon buildings as from the research. Actually, there is a range, irrespective of the building typologies or across the building typologies, it varies, leaving apart the iconic buildings which cannot be normalized or which cannot be taken into consideration. But the general variation, that range for example, for embodied energy, it ranges from 2.75 megajoules per square meter to almost 8.5 to 9,000 megajoules per square meter. 2.5 to 2.75 gigajoules per square meter to 9 gigajoules per square meter across all the building typologies. So this particular benchmark building, what is being considered for comparison, falls or gets validated from all perspectives. So now this is how we actually are establishing the benchmark values for a particular building. So now we have all the parameters which are required for comparison. Now, yeah, this is an interesting slide. I told you like I would include one or two interesting fact sheets, and this is one of them. This is the policy initiatives which we have taken, which have been taken in India. This is quite self-explanatory. Most important thing is it all started in 2001. That is an interesting thing. Energy Conservation Act was enacted in 2001. 2007 Energy Conservation Building Code came into the picture. 2007 green rating, GRIHA was also adopted as the national rating system for green rating buildings in India. 2015, we talked about Paris Agreement signed by almost 195 countries under the United Nations. 2016, National Building Codes included approach to sustainability chapter, and there are several policy initiatives which taken into consideration. These are some of the very interesting facts to know. As we know, Bhutan is the only carbon negative country in the world. It is the only carbon negative country in the world. They have the beauty of is the Bhutan's development, national development is not based on any GDP. I mean, the Bhutan's development or its national development is based on what is called National Happiness Index. So Bhutan is the only country in the world which talks about National Happiness Index of their countrymen, and then that is how everybody knows that if they cut one tree, they plant 5 trees. They know that the carbon sinks that have developed for carbon sequestration, that is carbon sinks. The lot of afforestation has been taken place, and that is how it actually becomes carbon negative. They are flushed. The requirement is mainly met with hydro power stations, and then the clean energy development generation is there. And Antarctica, second one is Antarctica losing 150 billion tons of ice every year. 1 unit of electricity is responsible for approximately 1 kg of carbon dioxide emission. Burning of carbon-rich coal of 1 ton emits 3.7 tons of carbon dioxide. This is very important. So you can imagine how much of coal we are burning. And then we are now, the recent permission or the auction of the coal blocks in India to push the industrial development, the economy further. Further actually deteriorate the condition. So it's almost about 1:3, 3.7. Then one mature tree will absorb about 1 ton of carbon dioxide in its lifetime of about 40 years. 40 years is the average matured lifetime of a tree. That is what is taken. A scenario where carbon dioxide concentration and maintained at 450 ppm is called as blue scenario. A scenario, I'm sorry for the repetition there. A grown-up tree gives about 120 kgs of oxygen and absorb about 25 kgs of carbon dioxide per year. We need, every man needs about 550 liters or approximately half a cubic meter of oxygen per day, or as per NASA, it is 0.84 kg per day of oxygen per day. Man needs about 8 mature trees to survive for 1 year. And you can now imagine with this, we actually can calculate how many trees we actually require in our lifetime. These are just interesting things for your reference. So let us come to how do we actually, now we have the benchmark values completely with us. And now let us come to how do we analyze a building. This is a scenario. I think this is one of the buildings which is taken from Bangalore itself. And this is the scenario in the urban scenario. Almost all buildings are like this. Though we may call it as, some people claim it as rating, some people claim everything, but generally this is the scene, high-rise buildings, what we have seen. So let us see how this particular building behaves like this. This approximately, the salient features of the building are, it's about 17 floors, 15 plus 1 or 2 basements, and then total area is about 2.5 lakh square feet, about 25,000 square meters. Envelope, the outside envelope is completely of solid concrete blocks, and then there is a tile cladding which you can see here, and then the internal walls are also solid concrete blocks, and flooring comprises of variety of flooring, vitrified, ceramic, wood, granite, natural stone, etc. The joinery, the doors are, majority of the doors are wooden, and doors and windows are UPVC, and then plywood shutters. Formwork is completely conventional type of formwork. And what exactly is the conventional formwork? We have discussed in our previous talks, so I would not like to elaborate on that. Waterproofing is a membrane type waterproofing. Climatic region, warm and humid. Seismic zone 2, green rating. This building, it seems, was analyzed and then given a particular certificate. I would not like to comment on that. And no alternative energy source, and concrete used is RMC M20 to M40. And I personally feel, as my experience goes, this actually is the general scenario across any urban city. This maybe all might be differ is probably the grade of concrete may differ, and otherwise this is the scenario in all multi-storied buildings. Now let us see how we analyze this. And now we are going to follow the same step as we followed in the benchmark process. So we need to understand and then calculate, even apply have a sustainability development index approach, we need to have all the parameters, including the embedded energies, as we discussed. So when we start looking at calculating the embodied energy per square meter for the entire area, here we have categorized it for, from the entire bill of quantities. We have categorized the entire bill of quantities into these subsystems. And also now in the inventories or where the data are available, there are certain inventories where embodied energy is expressed in terms of square meters. For example, megajoules per square meter. Otherwise, in the majority of the items, it is megajoules per kg is the embodied energy value is given. So we need to separate them also here, because the painting, formwork and membrane can be, formwork will never be available in any of the inventories as a separate unit. But formwork, as we have, that is the reason why I took and then analyzed it in the last class. So that is similarly, we have to do it for the different types of waterproofing as we discussed in last. So now analyzing that, this is the total quantity of the project which is given here in this particular column, and then quantity per square meter is calculated. We know that because we know the total 25,000 is the square meters. We know the embodied energy values and embodied energy. These are the total kgs. Convert them into the total per square meter value is converted into kgs using the densities, and embodied energy units are applied, and total embodied energy for the particular building per square meter is evaluated, which comes to about 5,185 megajoules per square meter. Now, which actually is about 5.2 gigajoules per square meter. Now we understand, and when we have this, the similar comparison can be made. Now it can be symbolically represented like like what is shown in the chart, and on the right side is actually the abstract of all the things what we have shown. This is the abstract of the case study what we are now talking about. Now this particular thing, now what does it mean? For example, see, the concrete works has an impact from embodied energy perspective to the tune of about 53%. Steel works to the tune of 22%, and so on. So what do we understand by this? Total embodied energy component for this entire building is approximately per square meter, we have calculated 5186. So approximately the total embodied energy comes to about 13 crore megajoules, rounded off to the nearest. And at 1 megajoule is equal to 0.2528 units, kilowatt hours. So we have 3.64 crore units, and at the rate of 8 rupees per unit, this has got a component of about 29 crores. So this building, particular building what we are talking about, has a component worth of about 29 crores as an embodied energy, as compared to benchmark value of about 3,522. See, here we have 5186 as the embodied energy value, and as a benchmark value we have 3,522, and when we economically analyze it, approximate saving will be about 9 crores. Actually, this is a hidden cost in the building, because we are actually paying for this. Because nobody gives, when the material comes to us, all these actually are taken from cradle to site boundary conditions, because we have not yet estimated the cradle to grave condition or cradle to cradle condition. So it is cradle to site, because we are talking about in the construction phase and pre-construction phase. So because the material comes, all the entire transport, everything, manufacturing cost gets included. So in the entire, if the entire cost of the project, what we are talking is about 100 to 125 to 150 crores. In that, approximately 30 crores is due to the embodied energy. And then if we reduce the embodied energy and then take it to the maximum extent possible, we can have considerable amount of saving. So this is an indication, and then this will help us to understand and evolve mitigation strategies. Now, this is as far as embodied energy is concerned. Similar exercise can be done for the embodied carbon part of it, and we use the same analogy. We have the total embodied carbon per square kg unit, and then per square meter, this is the total value. And when we represent in the similar condition, we have the same chart and then the tabulated form. And look at the here, what it means is, it is almost about 1 crore 22 lakhs is the carbon dioxide emission that is the component of that particular building. And economically, when we convert that, it approximately comes to about 9.2 crores worth. And this is the difference, 483.75 kg CO2 per square meter to 316. That means we have an option, we have a flexibility, we have a possibility to bring down the embodied carbon value from 483.75 towards 316. It may not be possible for us to reduce 483 to 316, but we may aim for sun but land up at least on moon. So even if we are able to reduce or touch 400 kg CO2 per square meter, it is a considerable reduction in the carbon footprint. What we are talking is only one building. You can imagine the amount of construction that happens across the city, across the country, across the globe. This amounts to a massive, massive reduction in the carbon footprint. So this is as far as carbon, embodied carbon is concerned. So now we come to the same interaction values, what we have talked about. And now in case of a benchmark value, we had the mean interaction value as 13,414, if you remember. And here we have 23,635. So these are the same interaction calculations which we have discussed, and using the same equations which it takes a lot of Excel time and then to do this, but it's not very difficult to arrive at these. See, once we have these values, and when we compare the individual interaction values, for example, reinforced concrete has got two ranges of 815 and then 1788. When we compare them to the total value, we understand how much percentage of impact individual parameter contributes as compared to the overall impact. So that is how we understand the impact of individual parameters, individual subsystem, and also the overall impact. And similar expressions of the things. And then you can see here, concrete has got only 7%, 7 to 8%. This particular, when it is chart is drawn, it is rounded off to the lower round figure. So steel has got 42% and formwork also has got about 43%. So all other things actually can be understood, and then this is how we should be able to arrive at a mitigation. And please believe me, what we are talking is not like the criteria concerned after the completion. We are not breaking our head, or we are not doing any post-mortem of the subject. We are analyzing the project when it is on the drawing board. So we have ample time to analyze and then reduce the carbon footprint. So this, so what does it mean? We have from 23,635 value, we can actually reduce it to 50%. We can come down to about 50%. So mean interaction values of each subsystem are compared with that of the whole system and then expressed in percentage, which I explained to you. Now, when we talk about the cluster of buildings, now we have talked about the individual building. What happens if, how do we apply this entire concept of Sustainability Development Index across the nation, across the climatic regions, where plenty of research, plenty of several countries have developed their own sustainability development index with reference to the local conditions and geography. And this, the one what we are talking is probably can be taken as India specific, because the climatic region is humid warm. Now, how do we apply it when we come to different projects? Now, let us say I've taken about 12 projects here. Okay. Now, these are the residential buildings similar to what the case study we have. Now, each building has to be analyzed the way we discussed just now. Each building, you will end up with the embodied energy of this much, and then SDI percentage of this much, and the embodied carbon of this. So these are the 12 projects. Now, once we have these projects, now we are analyzing. Let us assume that all these projects, 12 projects, are in a gated community. I am now slowly extending the application of the Sustainability Development Index from material we saw applicable to material, then we saw as applicable to an individual project or an individual system, then in individual project, and then to a cluster of buildings or to a gated community. Now we are talking about a gated community where we have about 12 projects. Now we need to apply some kind of statistics methodology and arrive at, because we have all the values for this thing, we can arrive at what exactly is the mean value for all the three parameters, then what is the standard deviation, what is the percentage variance of a percentage of variance. Then we also have the baseline values for these three parameters, which actually are forming the datum line for us to compare. And we also have the range values for each parameter. Once we are equipped with this particular all these benchmark values and other things, we should be able to understand, classify the buildings under these four categories. And what are these four categories? We can have the category, some buildings in the same gated community, what we are talking about, some may be non-sustainable, some may be least sustainable, some may be modernly sustainable, some may be highly sustainable. It's very difficult to say which is very highly sustainable, but I mean, this is just as a comparative chart for the comparison. We have it has been indicated like that. And what actually is our endeavor? Our endeavor is to move towards from non-sustainability towards sustainability, and that is actually the goal. Now we are talking about the classification of the buildings in a particular community. We have, as a case study, we have taken about 12 projects. Now, how do these baselines or classification is fixed? Now we have all the range values, baseline values, we have the mean value, we have the standard deviation, and plus or minus 15% with respect to baseline values and other variance lines. What we have worked at, upper limit and the lower limit are, and these upper limits actually are fixed based on the international computations as already discussed. This is how we have now, let us look at the chart from embodied energy perspective. Now, if you draw a graph between the embodied energy and the number of projects, see, this is the baseline value, what we have as 3.52 gigajoules per square meter is the baseline embodied energy value. And then based on, and we have the mean value of about 5.19. Then we have the standard deviation. So we get these two lines as the parameters. So now we are able to classify the building with respect to these lines with about 15%, approximately 15% increase as 4 classifications. Now, if all these identifications, what we see are actually the project values. For example, project value you see now for example, P6 actually has got the highest embodied energy. This is what we saw in the table, in this particular table. P6 has got maximum embodied energy of 5.96. Suppose we come back and then see how this P6 behaves as under what classification it comes. It actually P6 with 5.96 embodied energy just falls in the border region of non-sustainable and least sustainable line. So this is how actually there is no project except the benchmark project lies in the highly sustainable zone. Majority of the projects lie between moderately sustainable and less sustainable zone only. So this is how each project only from embodied energy perspective can be classified. And similarly, we can actually classify the similarly, we can classify the buildings on from the embodied carbon perspective. See, for example, there was a particular project which had about 515.23 kg CO2 per square meter as its value, and then you can see it actually falls in the again in the border zone. So this is how it is possible for us to classify the buildings when we apply it in the cluster zone. Believe me, this can be extended to any extension also. But the more and more we go and enhance the composition, it becomes the input matrix, input data becomes actually extremely complicated. How do we, for a cluster of buildings, it is possible to identify maybe in a gated community, but we extend it to a larger area or to a society or a part of the city, then the input matrix, the data collection becomes much more difficult. So there are several other methodologies which we need to adopt to understand the importance and then the data collection. The higher the accuracy of the data collection, the accuracy of all these sustainability assessment will be there. The biggest drawback in India is the availability of reliable data. And this is true with everywhere, but it is more so with the developing nations. So now this is the comparative chart as we are talking from the sustainability, sustainability developed index point of view, and each project actually can be understood. So now, as seen in the other areas, we have not, there's no project which falls under high sustainability, but again, they all fall under moderately sustainable and low sustainability from the sustainability point of view. See, there is one project which is project number 9, which actually when we go back and then see, it will have the highest interaction value. So that I don't remember the figure, but what I can do is, project number, this is project number 19. No, okay. This is one of the project which is and this is beyond the 12 projects what we have taken. So this is how we actually can be able to identify or classify the buildings. So next, now what exactly, I've come to the last part of it. So we have essentially seen from how we can actually at the conceptual stage, how it is possible for us to take the building from non-sustainability towards the sustainability, even in the conceptual stage. Okay. Now, sustainability, a sustainable assessment leads to sustainable development, and this is absolutely important for us. So with the help of sustainable development, it is possible to evaluate embedded energies as we discussed. Then we talk about, we can analyze the material suitability, which material can be used for a particular project, which is more suitable. And we all remember, we also discussed which kind of whether from figure of merit, from energy, from embodied perspective, how we can classify the buildings, building classification, material classification, building clusters analysis, what we just now, which can be enhanced to a larger community or to a society or even to a particular city. And when this, once we have the accurate data, the entire concept actually can be done. And then this is actually one of the processes, one of the ways which India is also presenting its sustainability development index and its development through the goals, sustainability development goals, which actually is the. Now, in what exactly is the takeaway, final takeaway? Decarbonization is the only way forward for us. We have actually reached the limit as we have done. It would be very, very wrong on our part to say that we have nothing to do. It would be rather foolish. We will be doing a great injustice to the future generation. So as civil engineers, whatever we can contribute, we should be able to take a positive step ahead. And decarbonization is the only way forward. How do we effect decarbonization? Energy efficiency, low carbon footprint, reduce the carbon footprint the way it has been discussed in the previous sessions. And fuel switching, of course, is not a part of us, but it is actually, we need to switch over from fossil fuel to the clean energy energies and increase the carbon sinks. What do we mean by carbon sinks? We need to increase the green area. We need to increase the forest area so that the carbon absorption in the atmosphere actually gets considerably increased, reduce deforestation, and foremost thing is control population and the migration. Our rural areas are not at all affected to the tune what we are discussing. Ultimately, these are the urban scenario is the word. And how do we decarbonize? Improve energy efficiency at site, adopt clean energy to the extent possible, adopt sustainable and smart construction, shift to re-engineer the high energy materials to be a part of low carbon economy, increase recyclability and reuse, manage waste smartly, use alternate and local materials, seamless integration with the nature. And dear friends, with this, I have come to an end. Thank you very much for your participation. And lastly, I would like to recall your attention where we as civil engineers are responsible for almost these 6 sustainability development goals out of 17 development goals, which are a part of the international agenda here. So we have a great responsibility, and more responsibilities towards the youngsters who are actually a part of this wonderful group. And I'm sure a lot of thinking and then a lot of churning will happen through these sessions which we have come. And then we as civil engineers will let us to the maximum possible, let us contribute to the sustainability development goals and make a carbon footprint, reduce the carbon footprint to the maximum extent. Thank you very much. And over to you, Ranganath.
Thank you, Dr. Ajit Sarnis. I greatly appreciate your enthusiasm and your time and the energy which you extended to share with all of us. I request all the participants here to give a clapping ovation. I'll unmute you all at the count of 3. Just give 3 claps in appreciation of Ajit Sarnis' efforts. Friends, I think we'll be moving on to the question and answer session now. Before that, as usual, I think the Secretary of Bangalore Center, Mr. Shrikant Chanal, is going to make a few presentations.
Thank you, sir. Thank you. Good evening once again. Evergreen Dr. Sabnis, sir. And we are enlightened by him and so many technical terminologies. Some of them we can understand because all these new terminologies we have never come across earlier, and these are the things which we have to be equipped. And now I think we have to still go deeper into that one, and deeper in the sense we have to learn seriously and try to adapt in our forthcoming projects. And in coming this thing, and definitely people will have a positive impact on the construction arena. Having said that, from ACC Bangalore Center, it is always our endeavor to do a good knowledge dissemination amongst all the engineering fraternity, so that everyone will get a good benefit, and the society also should get a benefit out of our efforts. In this, after this sustainability series, presently we have up to almost November end. After that, we are planning to start another series, what we call presently as a professional engineering series, civil engineering series, in fact. In the sense, many of our engineers, what we have observed is, are not aware of what the provisions are there in the NBC and what the rights and privileges kind of a things, which we are supposed to have it in our bylaws. The way we are taking the code books and following it up, there are other administrative parts which we have totally neglected, and many of us are unaware of the civil engineering provisions, that what should be there and what not should be there. And it is ACC's a very hard effort to put them in order, and making a lot of efforts with the concerned authorities and writing to authorities to implement. Not only just NBC, National Building Code of India bylaws, but there are other aspects also, professional issues, like what the bylaws they have and whether the bylaws are in order or not. Because in some of the cases, in fact, we have the records also, the stability certificate of a building designed as per IS earthquake resistant code has been given by an architect. It is not one or this thing. The provisions have been incorporated without having put their engineering knowledge or this thing, and such things we are actually pinpointing and bringing to their notice and trying to get it rectified. So such issues we are going to discuss, and what are the legal status of today's civil engineer, and how he is fighting for his status as well as for his professional recognition in India, abroad. So many aspects we are likely to discuss. And then there is another issue of unprofessionalism, which is popularly called as quacks, in private as well as in government. As everyone may be aware that in government bodies, many of the non-civil engineers like mechanical engineers, electrical engineers are doing the jobs of a civil engineer. Supervision, estimation, designing, everything they are doing. I don't know how far the government is taking this as a cognizance and taking this forward. So it is our duty to enlighten them. No, this is not the professional way that what you are doing. So this is another aspect that we are enlightening, what is to be done, what is not to be done. It is not just giving a lecture, but it is an interaction kind of a thing. Last 2 to 3 lectures. So in this way, another point to be discussed is as I was earlier explaining, 50% of the planned outlay of the whole India is spent for the construction industry, and in that 50%, another 50% will be going for the buildings and 50% will be going for the infrastructural projects. Now, the whole of the 50% is going for the building construction. Then how our civil engineering curriculum is equipped to deal with the buildings? In fact, once we studied about the civil engineering syllabus, now today we are not industry ready, or what we can say is the engineers are not employable directly. Why it is happening? Because our syllabuses are diluted. In the sense, most of the universities and most of the institutions have changed the syllabuses to such an extent that building the design parameters are say concerned with the buildings, the syllabus has been weakened, and that is the reason why our industries are suffering and they are not getting the employable. This is one aspect, and this also we are likely to discuss in the forthcoming series. I hope that will benefit all this thing. This today we are going to discuss in our management committee meetings also all these points. Friends, please await this series also after the sustainable series. Back to you, sir.
Thank you. Thank you, Mr. Shrikant. Now we are on to the question and answer session. I think I call upon Dr. Kalgal, who has a couple of questions on the subject today. Dr. Kalgal.
Yeah, thank you, Ranganath. I hope I'm audible.
Yes, you are.
Very much so.
Ajit, excellent presentation as usual. Nobody can be as passionate as you on sustainability. But you have to continue to do this for sustaining our interest into this particular field. So, first thing that I just wanted, I have actually three small questions, not very elaborate. First thing is, how do we choose this benchmark building? You said it has to be based on the same typology, same kind of conditions, etc. So if we are doing some projects and we want to compare our project with a benchmark project, would we be selecting the benchmark project, or somebody will select and keep it as the benchmark project for my area? How do we go about going forward?
I think I'll answer one by one itself. See, there is table to be used that as to which building has to be. There are some available the national point of view. It is basically a search, and then every benchmark building, that is what I said, it has to be actually validated by either by the other building rating system, etc. But we have now ample number of buildings under each typology, which can give us actually an indication towards to which building can be a benchmark building. See, we know the range that it varies from 2.75 megajoules to 9 megajoules per square meter. For example, embodied energy. 9 megajoules per square meter building cannot be the benchmark building at all. But now if we have about the framed structure, completely RCC high-rise building, and it also cannot be 2.75 megajoules per square meter. It should fall in the range of about 4 to 5 megajoules per square meter. That is where the benchmark projects are coming into the picture, and that is where the research listings are also available. So that is how we need to, and that is where the experience of come to the picture. It is this particular data is one of the important data which is not available to us, along with like other data, accurate data, which is not available. So even if we reduce by about 20%, 30%, 40%, that itself is a good journey towards sustainability.
Yeah, I fully agree. Only worry is that whoever is the benchmark building, he may not share his data with us. So we may not be able to do a proper, estimation or comparison. That's my That was my apprehension.
No, but
you
a
have-
consultant can definitely analyze the building based on the footprint. I'm sure he will be, most of them will be happily giving the data, but we can take the data and analyze it. It's possible.
Okay. The other questions are very small. One is you had compared the concrete with steelwork, formwork.
Yeah.
What exactly is steelwork? Because I saw that in concrete you have already taken reinforced concrete, which means I thought you might have taken reinforcement there. So what is the steelwork all about? I might have missed that point. You might have explained. What is
No,
steelwork?
no. It's basically a clarification where the reinforced concrete is coming. Steel quantity is not separately concrete. It is only reinforced concrete taking the effect of reinforcement into the concrete. That is how the inventory values come into the picture. The reinforcement and the structural steel value, etc., are taken separately under steel.
Okay, but for a residential building, will there be so much of steel work? That was my question.
For residential, see, it may not be for a very individual building. If you take an individual building, but when we take an urban scenario, and then, for example, when we take multi-story building where the complications are much higher, the steel quantity is quite high, because in foundation itself the steel quantity is quite. And in fact, if you take a bill of quantities and then analyze it, the steel quantity, for example, in this particular, it is approximately about 5 to 6%.
So the steel of reinforced concrete is calculated separately.
Separately,
The
yes.
concrete used for reinforced concrete, that concrete is taken separately. Okay, thank you. Last one.
It is basically, I will tell you, that is why it is a real-time data. How you see in bill of quantities, you give reinforced concrete quantity separately and then the quantum of steel separately. So that is how exactly the analysis has to be done.
Okay. The third one is, just for with your experience going forward now, this morning we were hearing Dr. Shailesh Agarwal on housing technologies and all that. We will have to make this part also mandatory for comparing the various technologies. Now they have come out with 6 major technologies based on which all the major government housing will happen. Keeping speed and economy in mind. But we also will have to look at steel consumption and so on, because they are looking at steel intensive construction also, because they want to achieve speed. One small clarification, in your opinion, between RCC and composite construction, where we have steel and concrete, which do you feel would be more sustainable?
Composite construction.
Okay.
Composite construction, because there is a very clear categorization. For high-rise buildings, there is a concept of this Fazur Rahman or somebody. Beyond up to 20, in case of high-rise buildings, up to 15 to 20-story building, RCC is sustainable. Beyond 20 floors, composite structure is sustainable. This has been proved also.
Thank you.
Thank you. Thank you, Dr. Kalgal. Next, I call upon Dr. N. Ramprakash. He has a question. Dr. Ramprakash.
Hello, Dr. Sabnis. Fantastic lecture.
Yes, sir.
One of the things I was just asking you was that how organizations like the ACCE can imbibe these things in day-to-day practice is the first question. I have some corollaries to that.
Okay.
If you want, I'll tell them now, or I'll tell after you have answered.
Yeah. I think I will, because my memory is bad, so I may forget your second question itself.
Yeah.
So, this is actually takes forward Dr. Kalgal's question. We have lot of role to play as an organization. First of all, ACC is an organization with tremendous amount of specialization among our members, have to impress upon the builders the developers, that there are mechanisms where we can actually analyze the data, not as a post-mortem after the construction is done, but much earlier to that. And this is what actually we have discussed. These are actually the actual case studies taken, and analysis can be done. So similarly, we have to impress upon, as an organization, as an institution, not only impress upon the developers community or the other fraternity, and also on the architects, that these possibility of knowing the values and knowing the sustainability assessment is possible on the drawing board stage. This is one part of it. And then ACC as an organization should actually evolve its own rating mechanism based on all these sustainability. I think we have a long way to go, but we should evolve a rating system which actually can be integrated and complementing with all other green rating systems which are available. We can immediately take a step forward to get integrated with, let us say, IGBC or the other Griha or any other things who are like-minded people. I don't know how the receptivity will be there, but a step can be taken forward in this direction.
Okay, I have 3 suggestions. I'll bounce it off you. First one is the peer review system which you have for buildings. I think it should be specific for sustainability in one way. Is one of the systems which can control sustainability. The second one is this awards brings competition. You know, when we have awards on sustainable buildings, the best sustainable building or what have you, the second possibility. And the third one is some carrots to achievers in GST or licensing fee or one of those things.
Yeah.
You know? So these are the 3 possibilities. I mean, I want to bounce it off you.
No, absolutely fine. As far as the concession and then incentives are concerned, for sustainable building, I think some of the states have already applied it. If I'm not mistaken, Gujarat, there is some kind of incentive on this thing. I don't know whether Kalgal knows about it because he keeps moving to all the states. And we have Kuteji also, other participants from other states. But all the 3 things what you have suggested can be actually ACC as an organization, we can take it forward.
Okay.
Major role.
Yeah, I'm just saying that the role of ACC should not be, to talk to builders, to talk to architects, and all those things. The full fraternity of construction we should address. And we should tackle in these lines. Okay.
It should be a part of the regulatory system.
Okay. Thank you.
Thank you, Dr. Ramprakash. I think you have addressed your points to the right person in the association. Dr. Rajesh Sabnis is a sustainable man in the association. We have a working group called ACCI Institutes, of which Dr. Rajesh Sabnis is the chairman. And in fact, this particular series is designed and being conducted by the Institute working group. And I'm sure there are a lot of points that need to be copied on from whatever suggestions that are given. And I'm sure the Institute working group under Dr. Sabnis is going to achieve a lot more things. Next, I think Mr. Prakash Munnoli has a question. Prakash? Mr. Prakash Munnoli? Yeah. There is another question by Mr. Ajit Kumar. Ajit Kumar, are you there?
So you can read the questions if you are there.
I'll read out the question.
Yeah.
As you mentioned of smart and sustainable building, can you briefly explain how to construct the same? That's the question, Ajit.
Yeah, no, we have talked about in all the previous sessions. I have covered the green construction and sustainability construction design parameters, everything. I would request Ajit to go back to all the presentations which are readily available available to everybody on this thing. I think this was discussed in the third session quite elaborately. All the design parameters and everything was discussed. So it cannot be discussed in such a small thing. Probably it needs another long session, how actually implemented. But this has already been discussed, Rajit. You can kindly go through. If you have any doubts, you can get in touch with me and we can discuss separately.
Thank you. Next, Dr. Balaji NC. Would you like to ask a question, Dr. Balaji? Or I'll read out the question what he has posted. Ajit, if 4 to 5 megajoules per square meter is benchmark, then how many studies have been carried out to make this value as benchmark?
I really don't know how many studies have been carried out because there is no data to evaluate every research and then keep track of it. I don't know if Raghu is there, Dr. Raghunath is there, whether he is able to throw some kind of a research done and then documented because he is from the academic field, or even Kalgal, I think, both of them being from the academic field, if they are able to do it. But as I have seen, there are at least about 200 or more than researches where the ranges have been given in this range, 4 to 5 megajoules. I think, Raghu, are you there? Dr. Raghunath?
Dr. Raghunath, you must have left.
Yeah.
Okay. Now, I think this question is also from Dr. Balaji.
Yeah.
These lead IGBC and Gruha, which is recognized by the government or which is more professional and reliable?
See, LEED is a US based, is based on USGBC, and similar thing has come on to India. India has adopted the same criteria, and it is called IGBC. And as far as India is concerned, IGBC, which promotes Griha and other rating systems, is more accepted by the government of India. And all other things are actually a private green rating systems. We have green rating system from US. Leads, though it is lead US, it will depend across the green, and then other green rating system from UK, from Singapore, and from Australia. Several these things are slowly coming into the picture, and these are actually criteria-based green rating systems which actually have to come into the picture. So TERI also has its own green rating system, and green rating system also we discussed in our previous sections. There are several green rating systems and the criteria also have been discussed. I request Balaji to kindly go through the previous session presentation.
Can I just add one line?
Yep, please.
Basically, IGBC is supported by Confederation of Indian Industries, CII, and Godrej. Okay, so they follow, as Ajit rightly mentioned, they follow USGBC, but they have changed it slightly to make it more Indian oriented. Griha is proposed by TERI and it is supported by Ministry of Renewable Energy and Resources. So obviously government favors Griha because a government department is connected to it. And what they have made, they have issued a circular that all the government buildings have to follow Griha, which means it appears that government is a little leaning towards that. But then according to BMTPC, they say both of them are valid because you know, there are right now no incentives for being accredited as sustainable building in terms of fiscal, but there are other benefits like someone can boast that his building is platinum certified, etc., where he will get a better market value maybe in private sector. So both Griha and IGBC, that is lead India, are valid and are on equal footing according to me. Probably Griha is one step higher because for all government buildings, Griha rating is a must.
Thank you, Dr. Kalgal. I think there is a question from Mr. Satyanarayanan.
Good evening, Dr. Ajit.
Yeah, good evening, sir.
Only thing, you were telling the good thing is, to start from the drawing board. But unfortunately, what happens is we have already constructed a lot of buildings. So we have, what all the details required for, maybe around 20, 30 buildings of various, floors, ranging from 8 floors to 25, 26 floors. We have the complete quantities and what has gone inside. We know that. Is it possible to go back and check every E of each buildings and then come to some kind of what kind of the ratings it has taken, and then is it possible to apply that onto the new projects? Would it be good?
Yes, sir. That I think that is one of the most need of the hour. The biggest problem is why we fail in collecting the data is no builder wants to give the details of his particular building because it is not sure whether it is truly sustainable or not.
Okay.
From that, see, we know plenty of well-rated buildings, but subsequently, how long does it go into consideration? But when we analyze the buildings, especially when the buildings, what you're talking, when we analyze them and form an extensive database, and that will probably answer all the previous questions what one of them have raised. How do you know that 4 to 5 megajoules per this thing is the benchmark?
Yeah.
Suppose we may actually, if every is it architect Satyanarayan by any chance?
No, I'm from the construction. I'm the
All right. This will be a wonderful, but if everybody gives this actually genuine data that is available, which actually has already executed, and we can definitely arrive at excellent comparative statements and in fact arrive at a benchmark without getting into the benchmark details. We can contribute to that. It is possible.
No, let us not name
And
the
that should be
builders
done.
or anybody. So what we can do is, I have data of more than 30, 40 buildings. What I can do is I can provide the data details. Okay.
Yes.
And then, whether that can be utilized location wise, we can work on that.
We can.
Including government as well as, private this thing.
Sure, sir. Sure.
Okay, right. Thank you, sir.
Thank you very much.
Thank you, Mr. Satyanarayan. Any other questions? Okay, there is a statement here made by Mr. Gopalakrishnan supporting Dr. Ramprakash's observation earlier. In ACCE, we can think of a national award in sustainable energy category. I think that's a good suggestion, which I'm sure it will be taken note of by the Bangalore
I'm
Center.
sure if President is a part of this meeting, he would take a note of it. And awards committee chairman also will take a note of it.
Okay, thank you. If there are no other questions, I think we'll be ending today's presentation. I would like to just announce that the next presentation will be on role of alternative materials in reducing the carbon footprint of buildings. That will be next Saturday, that is the 31st of October at 4:30 sharp, and it will be presented by Engineer K. Rajkumar. I now call upon the Secretary of the Bangalore Center, Engineer Shrikant Chanal, to propose vote.
Thank you, sir. And good.
I think you're getting cut, Shrikant. You have to unmute yourself. Yeah, go ahead.
Yeah. Thank you very much, all the participants. Hope you have a lot of inputs have been given by Dr. Ajit, and hope everyone will try to achieve at least to some extent some sustainability. And in fact, to share one of my experience after discussion with these lectures, my daughter was asking greenhouse gases because she was having certain doubts in her studies. I told greenhouse gases are nothing but they are like Chakravyuha, and energy is like once that Abhimanyu enters the Chakravyuha, he will not, and he will be trapped inside the Chakravyuha. And I gave this answer. She enjoyed it a lot and she remembers it very well. So some of the things, and really I am also enjoying becoming part of the sustainability. Hope we all will practice sustainability. And with this, thank you very much, and have a nice Saturday weekend evening. And happy Dasara to one and all. Thank you. Thank you.
Thank you.
Thank you. Thank you. Thank you.
Thank you all, and namaste.